What's up, YouTube? Let's talk about aircraft gas turbine engines, or should I say, an introduction to aircraft gas turbine engines. We're going to go over the major components and try to explain how everything works and how to apply some basic engineering principles. So let's start with going over the major components. And I like to start at the front of the engine and move backwards towards the aft part of the engine. So at the front of the engine, you have the compressor. Behind the compressor, you have the combustion chamber. And then at the back of the engine, you have the turbine. And somewhere external to the engine itself, you have what's called the starter, which is important in the starting sequence. And so what I'm going to do here is try to explain how the engine works by starting with how the engine starts. So let's see how this goes. So step one is you initiate the starter, and basically what the starter does is it rotates and it's engaged with the drive shaft inside the engine. So as the starter rotates, the drive shaft inside the engine rotates, and remember that the drive shaft is inside the engine is what connects the compressor to the turbine. So you've initiated the starter, and now the starter is starting to rotate the engine, and it's going to rotate it at a prescribed acceleration schedule. By that I mean it's just going to start spinning faster and faster and faster. And so as your engine starts spinning faster and faster and faster, because the starter is rotating faster and faster and faster, you're going to add fuel to the engine. And so as you add fuel to the engine, you're no longer going to have just energy input from the starter, you're also going to have energy input from the fuel. And so I'm using words like energy and stuff because I want to throw some engineering terminology at this. And so really the concept here is called the first law of thermodynamics, which most people have heard before and can say energy is never created or destroyed. We all know this to be true, and most engineers know how to put this in an equation that says energy in equals energy out. So at the beginning of this start sequence, our primary energy input is the energy from the starter itself. But as you increase the speed more and more, or as the starter increases its speed more and more, and you apply more and more fuel, you're going to add in the energy addition from the fuel. And what's going to happen is, if you compare the energy input from the starter versus the fuel as you approach the idle speed, which is where the starter disengages and the engine runs based off of fuel alone, is you're going to see basically less and less input from the starter and more input from the fuel. And then when the engine reaches its idle speed, which is the speed that it can operate without the starter, basically by itself with the fuel, you'll see basically the primary input being from the fuel itself. How does adding fuel to the engine keep it rotating? Or better yet, how does adding more and more fuel to the engine make it rotate faster and faster? And the answer to this question is energy conversion. By that I mean conversion of the chemical energy stored within the chemical bonds of the fuel getting converted into heat added to the gas flow within the combustion chamber. And this can be in the form of a increase in pressure or velocity of the gas in the combustion chamber, most likely depending a lot on the geometry of the engine. But what the turbine does with this is it extracts this energy to spin the drive shaft of the engine. And it does this by converting the energy from the heat addition of the combustion products into work. And the way I like to look at a turbine is almost as if it's a windmill. So you have the gas inside the combustion chamber entering into the turbine, and it impacts the turbine blades and makes them spin. And the amount of work done on the turbine blades is equal to the force of which the gas hits the turbine blades times the distance by which they travel. Now I'd like to point out that not all of that heat added to the gas flow from the combustion of the fuel goes towards spinning the turbine. Some of that energy is in a sense lost, and we know that it's lost because of the second law of thermodynamics, which basically says that if you put a hot and a cold object next to each other, that the hot one will get cooler and the cool one will get warmer until they reach some sort of in between temperature, and there is no longer heat transfer between the two objects. And we have to remember here that when the engine is just starting, that the engine components that are directly in contact with these hot combustion products are not yet warm. They're just now being exposed to the hot air. So you have, or excuse me, the hot gas. So now you have heat transfer in the form of convection from the combustion products or the gas to the surrounding engine components, and that energy is not available to work towards spinning the turbine. Now, once those engine components are warmed up, or there is or a closer or less of a temperature differential between the engine components and the gas itself, you'll lose less energy in this way, and there will be more energy available to spin the turbine. But I do want to point this out because I mentioned earlier that we're looking at this in terms of engineering concepts, and the first thing I threw out was the conservation of energy, and we are conserving energy here, and we have to note that not all of that energy from the fuel will always go towards spinning the turbine, because we can in fact have heat transfer between the gas and the surrounding engine components. So now let's get back to the turbine. So the gas flow through the combustion chamber goes into the turbine, and it spins the turbine. It's doing work on the turbine. And so what is all that work going towards? And the answer is that work is going towards compressing the air in the compressor section of the engine. So how does the compressor add pressure to the air flowing through it? The answer to that question actually depends on the design of the compressor. For this video, we're just going to talk about axial compressors, which basically consist of multiple stages of stationary vanes and rotating blades. And the best way to look at this is to start with looking at the rotating blades, and you can kind of compare them to, say, mini airplane wings. So let's do an airplane analogy here. So let's say you have an airplane flying through the air, and you're looking at the cross section of the wing, which is called the airfoil. The airfoil is designed such that air flowing over it has to travel a farther distance over the top of the wing than the bottom of the wing. And because it has to travel that farther distance over the top, the airspeed over the top of the wing is faster than the airspeed on the bottom of the wing. And because of that increase in velocity, or that faster velocity on the top of the wing, the pressure has to be lower in accordance with Bernoulli's equation. So you have high pressure on the bottom of the wing, and you have low pressure on the top of the wing. So now let's go back to the compressor. You're looking at these rotating compressor blades, as many airplane wings. You can view the back of the blades kind of as the bottom of the airplane wing, and the front of the blades, the top of the airplane wing, and from that you can see that the pressure is higher on the back side, and you have multiple stages of these compressor blades, so the pressure gets higher and higher and higher as you move towards the combustion chamber. Now remember those stationary vanes that are forward of the rotating blades. The purpose of those is to make sure that the airflow coming into those rotating blades is in the right condition for the blades to work properly. If it's not, then the compressor could exhibit a stall or a surge. So that's all I really wanted to discuss for this video. We went over the major components of an aircraft turbine engine and how they work. We went through the start sequence. We learned how the engine starts by using a starter to spin the drive shaft and get the air flowing, and how fuel then takes over in spinning the engine by doing work on the turbine, and that work is used by the compressor to pressurize air coming into the engine, and the engine can thus sustain operation or rotation from that point on just by maintaining that fuel flow into the engine. Thank you for watching, and be sure to subscribe. I have a lot of ideas for future videos that I'm pretty excited about, and that's all. We'll see you next time.